Hey everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this problem on complex exercises, which says find the real part of Z and the imaginary part of Z, considering that Z is a complex number. Okay, Z is defined by this expression, which is 1 plus e plus all until 1 plus e all to the power 99. Okay, first of all, we realize that Z is written in terms of a sequence of a lot of terms. We have first term, second term, third term, fourth term, and the last term. So having this sequence, we have to check if it's arithmetic or geometric. It's arithmetic if the difference between the next term and the previous term is constant, and it's geometric if the ratio between the next term and the previous term is constant throughout the sequence. Okay, so if we check if it's geometric, first, then we have to divide the previous term by the first one, or the next term by the first term. This will be, we have to check if it's the same as this one divided by this one. And if it's the same as this one divided by this one. Okay. And we can check if it's constant. If we check, any number divided by 1 is still that expression. So it will still be 1 plus e. Here we can cancel this with this, will be 1 plus e. And the same here will be 1 plus e. So we can say it's going to be 1 plus e, which is constant, which is the constant that we get. So it's a geometric sequence. So since it's sum of 99 term, which is under term in other words, because if this is 99, this one definitely is another term. So this is under term. So that's what we have. Okay. Because we can say this is 1 plus something all to the power 0, which is, there is no need to do. Okay, doing that, we know that the sum of term, which we know in geometric, is the first term times 1 minus the ratio to the power n over 1 minus the ratio, which is the constant that we've just found, which is 1 plus e. So n, what is the value of n? We have to know what is the value of n. How many terms do we have? We have first term, second term, fourth term, and if we go, we will realize that this is the hundredth term. Okay, so now we know that n is equal to 100. Many will make mistake by assuming that n is equal to 99, which is not 99, it's 100, because it's counting each term. If this is 99, this is 1, then definitely this is term 0, which is also considered. So n is equal to 100. So n being equal to 100, we're going to find as 100. The first term is 1 minus the ratio, it's what we found, it's 1 plus e to the power 100 over 1 minus the ratio, which is 1 plus e. Okay, perfect. Now this expression, let's work this expression outside. So we're going to have that 1 plus e to the power 100 can be written in terms of 1 plus e to the power 2 all to the power 50. Okay, this one, if we expand it, it's going to be a squared, applying that formula of a. Let me just write the formula here first. Of a plus b squared is equal to a squared plus 2ab plus b squared. Okay, that's the formula that I'm talking about. If we apply it here, we're going to have, this is going to be 1 plus 2ab, which is 2e, plus e squared over 50 to the power 50. Okay. E squared is -1, so with this -1 they can cancel out, so we remain with 2e to the power all 50. So we're going to have 2e to the power 50. Okay, that's what we have. So that means this expression is equal to this expression, but it's not finished. because we can say this is 2 to the power 50 times e to the power 50, which can be written as e squared all over 25. E squared is negative 1 to the power 25. This expression will be negative. This expression will be negative. So we can simply erase this side. So this expression is equal to minus 2 all to the power 50. So we can replace it here. We're going to have s 100 will be equal, we have 1, this negative, and this negative will become positive, so plus 2 to the power 50 over negative will enter, 1 will cancel, and minus e. We have minus e. So if we multiply both the numerator and the denominator by e, here will be minus e squared. E squared is minus 1. With this minus will be positive 1. So we're going to have, in other words, that the answer will be 1 plus 2 to the power 50 times e, which can be written in terms of 0 plus 1 plus 2 to the power 50 e. So this is equal to z, because z is the expression that is written in form of these sequences. So that means the real part that we are required to find of z will be, now the real part will be 0, and the imaginary part of z will be this expression, 1 plus 2 to the power 50. Okay, that's how we will solve this problem. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.